Hi, hello friends. Welcome to our channel Study of Mathematics. From today onwards, we will discuss Maths 1A. Maths 1A. In Maths 1A, the chapter 3, Matrices. We will discuss the chapter Matrices. In this chapter we will discuss all definitions, example problems, exercise problems, and all total details of the matrices are explained in this chapter. First, we know about the definition of a matrices. Matrices is the plural form of the matrix. Matrix means one single. The plural form of the matrix is matrices. First, we know the definition of matrix. Matrix is an ordered rectangular array of elements is called a matrix. Matrix definition is an ordered rectangular array of elements is called a matrix. Matrix is nothing but the ordered rectangular elements of a ordered rectangular array of elements is called a matrix. That means a matrix is the matrix name is denoted by capital letters, capital A, B, C, and so on, capital Z. The matrix names are denoted by the capital alphabetical numbers, capital A, B, C, and the elements in the matrix are denoted by the small alphabetical numbers and numbers. That means, for example, capital A equal to 1, 2, 3, 4, 5, 6. This is one matrix. That means an ordered rectangular array of elements. That means the elements are arranged in a rectangular shape and in a column and row wise. This is called a matrix. In this, these are the rows and these are the columns of a matrix. These are the columns of a matrix. Horizontal array is called row. Horizontal arrays are called the rows and vertical arrays are called the columns. Columns of the matrix. Then next we find out the order of matrix. Order of matrix means a matrix having m rows and n columns is said to be of ordered m by n. Read as m cross n or m by n. Then if any matrix A having m rows and n columns, then the order of this matrix A is denoted by m by n or m cross n. In the same way, in this A matrix, we have 2 rows and 3 columns. Then order of A means 2 by 3. M are rows and n are columns. Then here 2 rows, then 2 by, here we have 3 columns, then the order of this matrix A is 2 by 3. For all compact matrices, in compact form of the matrix is denoted by the letter capital A equal to Aij of m by n, where 1 less than or equal to I less than or equal to m and 1 less than or equal to j less than or equal to n. This is the matrix general form. Capital A equal to Aij of m by n. Here are m rows and n columns are present in the matrix A. And here I comma j or I is lies in between 1 and m. J also lies in between 1 and n. M means number of rows, n means number of columns. For example, this can be written as if m is 2 and n is also 2, then A equal to, in the general form, A11, A12, A21, A22 of order 2 by 2. This is A11, A12. This first one is number of rows, the first row. First row, first element means A11. First row, second element A12. In the same way, second row, first element A21. Second row, second element A22. In expanding, first row, third element becomes A13. If the third element is also present, A14 and so on. Here A23, A24 and so on. This is the matrix definition. Next, we will go to the types of matrices. Next, we will discuss the next topic is types of matrices. In the types of matrices, there are so many types. In the first, square matrix. Square matrix. Already we know square means all sides are equal in length. That is already we know. But in square matrix, a matrix in which the number of rows is equal to the number of columns is called a square matrix. That means if A equal to Aij m by n is the general form of the matrix form, in that m is the number of rows and n is the number of columns of a matrix A. But if A can be called as a square matrix, then in A the number of rows and number of columns are equal. That means here m equal to n. If the number of rows and number of columns becomes equal, then that matrix A is called the square matrix. That means A in square matrix general form is capital A equal to A of Ij of m by n. Sorry, m by m. Here we have the m rows and m columns. Next, in that capital A of Aij m by n is a square matrix if m equal to n. Same. In this case, we say that A is a square matrix of order m. That means this m can be called as a order of the matrix. This m or this m, both are equal, called the order of the matrix A. Order of the matrix A. Next, if A equal to Aij is a square matrix of order n, the elements A11, A22 and so on ANN are said to constitute its diagonal or principal diagonal. In this, A of Aij of n by n of order n is given, then in this form all the elements, that means this can be written as A11, A12, A13 and so on, A1n, AN1, ఇక్కడ A21, A22, A23 and so on, A2n and so on and so on and so on. Here AN2, AN3 and so on, ANn. This is the matrix form of the general form. In this is a square matrix. Square matrix means the number of rows and number of columns are both are equal. Then this A11, A22, A2, A33, A44, A55 and so on, ANn are called the diagonals of a matrix A or principal diagonal of a matrix A. These elements are called the diagonal elements or principal diagonal elements of a matrix A. And also these sum, all diagonal elements sum is called as the trace of a matrix. Trace of a matrix A. That means trace of means TR of A. Trace of matrix A is equal to A11 plus A22 plus A33 plus and so on plus ANn. Trace of a matrix A is denoted by the letter TR of A. That means the sum of the elements of a diagonal of square matrix A is called the trace of A. To find the trace of A, first we observe the given matrix is a square matrix or not. If that matrix A is square matrix, then next we have to find the principal diagonal elements. Then the total principal diagonal elements sum is called the trace of the matrix A. Next, the second type of a matrix is diagonal matrix. Diagonal matrix. The definition is, if each non-diagonal element of a square matrix is equal to 0, then the matrix is called a diagonal matrix. The definition of a diagonal matrix means, if each non-diagonal element of a square matrix is equal to 0, then the matrix is called a diagonal matrix. That means if A equal to zero, non-diagonal, okay, 2 0 0 0 1 2, sorry, 0 1 0 0 0 1. These are the diagonal elements. The given matrix is a square matrix of order 3 by 3 and the diagonal elements are 2 1 1. And if this A matrix can be called as diagonal matrix, then the non-diagonal elements of a square matrix is equal to 0. Then the remaining elements except diagonal elements. Non-diagonal elements means the elements which are not in the diagonal elements. That means in the same way, A 0 0 0 B 0 0 0 C. In this is a square matrix of order 3 by 3 and A, B, C are diagonal elements. Then 0 0 0 and also 0 0 0, these three are called the non-diagonal elements. If these non-diagonal elements are equal to 0, then we say that this matrix is called the diagonal matrix. If any one this is a 1. Any one element of a non-diagonal element is a non-zero, then this is not called as a diagonal matrix. If all the non-diagonal elements are equal to 0, then only we say that matrix is a diagonal matrix. Next, third type of a matrix is scalar matrix. Scalar matrix sum. The definition is, if each non-diagonal element of a square matrix is 0 and all diagonal elements are equal to each other, then it is called a scalar matrix. Scalar matrix is Scalar matrix is a matrix. Scalar matrix is a square matrix. Scalar matrix is a square matrix, and each non-diagonal elements of a matrix is 0. In this, for example finding, we can take scalar matrix of 3 by 3 order. Then non-diagonal elements are 0. That means 0, 0. Here also 0, 0, 0. The diagonal elements, if the matrix A is called a scalar matrix, then all the non-diagonal elements are 0 and the diagonal elements are same elements. All the diagonal elements are equal to each other. That means in all diagonal elements, the element is same. In any place, the element is same. That means for confirming the given matrix is scalar matrix, first we sum given matrix is a square matrix or not. If that is a square matrix, then the next condition is all non-diagonal elements are 0 and also the elements or the diagonal elements are all equal to each other. The diagonal elements are equal to each other. Then this matrix is called a scalar matrix. If any one of the diagonal element is not equal to other, then this is a not scalar matrix. If all diagonal elements are equal to each other, but the non-diagonal element, one element is other than the 0, then also this is not taken as a scalar matrix. If one matrix is said to be a scalar matrix, then all the diagonal elements are equal to each other and the other diagonal elements are equal to 0. Then only this matrix is called a scalar matrix. Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.